Today we will talk about confidence intervals. So, picture this. You're trying to find out the average height of school students in your city. Of course, you can't measure every single student. That would take forever. So, you take a random sample of, say, 100 students. You measure their heights, do some math, and find the average is 168 centimeters. But here's the question. How sure are you that this number represents everyone? Maybe your sample was a bit taller than average, or maybe shorter. That's where confidence intervals come in. A confidence interval gives you a range that says, we're pretty sure the true average lies somewhere between these two numbers. Instead of saying the average height is exactly 168 centimeters, you might say it's between 165 and 171. That range is your confidence interval. Now, why do we call it a confidence interval? It's because we're expressing a level of confidence, usually 95%, that the true value lies within that range. If we repeated the same sampling process 100 times, about 95 of those confidence intervals would include the true population mean. It doesn't mean there's a 95% chance that this particular interval contains the true value. The truth is fixed. It's either inside or outside that range, but the method we use to calculate it has a 95% success rate in the long run. Here's an analogy that might help. Imagine you're trying to hit a target with a bow and arrow. Every time you shoot, you draw a circle around the arrow where you think the bullseye might be. If you're accurate about 95% of the time, that means that in the long run, 95 out of 100 of those circles would actually contain the bullseye. The bullseye never moves, it's the same every time, but your aim and the circles change a little with each shot. Confidence intervals are powerful because they remind us that data comes with uncertainty. Instead of pretending we know the exact truth, we admit what we don't know and quantify it. But here's where people sometimes get tripped up. A 95% confidence interval isn't a magic guarantee. It doesn't mean we're 95% certain the truth is in that exact range. It means that our method of constructing the interval has a 95% success rate if we were to repeat the study endlessly. It's subtle, but that distinction is what separates sound statistical reasoning from sloppy interpretation.